number 12, find an expression for h of g at x and simplify. So we're going to substitute g into h. So everywhere we see an x, we're going to put 3x minus 2 into h. So this is going to be 15x minus 10 over 3x minus 6. So yeah, the only other thing we could do here is factor out the 5 maybe. And 3 down here, but we can't do anything else with that. So for b, if we want to solve the equation that equals 0, I think I'll just use this one because when we cross multiply by 3x minus 6, we just get 15x minus 10 is 0. And then if we add 10 and divide by 15, and then 5 goes into both those, 2 over 3. 13, if we want to substitute g into f, so just rewriting it like this. And we're substituting x plus 2 into f, so we're going to have 3x plus 2. And for b, we want to show that the inverse at 18 plus the inverse of f plus the inverse of 18 at g is 22. So f inverse of 18, that's just where we have 18 equals 3x. So x is 6. And then if we have the inverse of g at 18, that's where 18 equals x plus 2. So x equals 16. So the inverse at 18 plus the inverse at 18 of f and g is going to be 6 plus 16 equals 22. All right, so for a, if we want to find the inverse of x, we're going to do x equals 2y plus 1 and solve for y. So that's x minus 1 over 2 is y, and we write it in inverse notation. For b, g at f at 2, negative 2, sorry. So f at negative 2 is when we have 2 times negative 2 plus 1, which is negative 3. And if we have g at negative 3, that's 3 times negative 3 squared minus 4. So that's 9, 27 minus 4, 23. And for c, f of g at x, we're substituting g into the f function. So 3x squared minus 4 plus 1. And you can simplify. 6x squared minus 8 plus 1 is 6x squared minus 7. All right, 15, we've got the function. X has to be less than or equal to 3 over 2. So we're just setting the y, because remember, f at 5 would be where you substitute an x in as 5. And here, it's the opposite. So this is becoming your y of your original function. So we have 3 minus 2x, and if we square both sides, and then subtract 3, which is 22, divide by negative 2, it's negative 11 is x. So this one, if we substitute in to g, so f at negative 2, and f at negative 2 is negative 2 cubed minus 4, which is negative 12. And that's 2 times negative 12 when we substitute it into g, so negative 24. So for b, we have x equals y cubed minus 4. So x plus 4 is y cubed, and you can do the cubed root of x plus 4, or you can do x plus 4 to the 1/3, and that is the inverse. All right, so for a, f of g at 4, so we want 1 over 4 minus 3, which is just 1. and 2 times 1 is 2. For B, we want the inverse of G, so we've got x equals 1 over y minus 3. For this one, I know in class we multiplied it out, but when it's not y top and bottom, you don't have to. So we have this when we cross multiply. Here we can just divide by x and then add 3. If we did cross multiply it out, we'd have xy minus 3x equals 1. And then we would have 1 plus 3x. And we'd have 1 plus 3x over x, which makes sense if we got the denominator of x. So either one of these work. And don't forget function notation in both. So that's the inverse. For C, write down the domain of the inverse. So that's the range of the G function. So the range of the G function, so when it's rational like that, we're going to have an asymptote at y equals 0. Okay? We'll deal with other different types of asymptotes, but, well, I guess we could just do that. I mean, you can do it from the original function, or you can do it from the inverse function. So clearly here, the domain of the inverse function is that x can't be 0. So yeah, that's the answer, because you can't divide by 0. Okay, so if we have the inverse at 2, we're just doing 2 as the y. So subtract 5, which is -3, divide by 3 is -1. And for B, g of f at -4, so we have g f at -4 is 3 times -4 plus 5. So that's going to be g at -12 plus 5 is -7. And that's going to be 2, 1 minus -7. And that's 8 times 2 is 16. All right, for A, g of f at x, so we're substituting cosine into g. So we're going to have 2 cosine x plus 1. B, we're doing 2x plus 1 into the cosine. That's going to be cosine 2x plus 1. And C, find g into the inverse and the inverse into g. So these both should be x, and I see 2 marks, so I wouldn't really go further than that. But if we were to show this and find the inverse of g, so we're going to have x minus 1 over 2. That's the inverse function. And if we have g inverse of g, that is going to be 2x plus 1 minus 1 over 2, which is clearly x. And if we do g of the inverse, we're going to have the inverse 2x minus 1 over 2 plus 1. The 2's cancel, and x minus 1 plus 1 is x. All right, 21. So we need the inverse of g. So we're going to have x equals 6 minus y over 2, multiplied by 2. And then I'm just going to add y and subtract 2x. So that's your inverse. And b, if we want, okay, so we need to put the inverse of g, oh, this is g, sorry. The inverse of g into f, so we're going to have 4, 6 minus 2x minus 1, like that. And and we want that equal to 4. So if we divide by 4 first, that's going to be 1. And 6 minus 1 is 5 minus 2x. Subtract 5 is negative 4, and divide by negative 2 is 2. Okay. All right, 22, the inverse of g, we have x equals 2y minus 3. And x plus 3 over 2 is the inverse of g. And f of g at 4. So if we substitute 4 into g, we're going to have 2 times 4, 8 minus 3, which is 5. And f at 5 is 25. 23, if we substitute f into g, we're going to have, so g of f is going to be 7 minus 2x plus 3, which is 10 minus 2x. So for b, we want the inverse of g, so we have x equals y plus 3. So we're going to have x minus 3 equals the inverse of g. And for c, we want to substitute into the inverse of g 5. So g inverse 5 is 5 minus 3, 2. And then we want f at 2, which is going to be 7 minus 4, 3. All right, so h is f of g at x. So we want to substitute g into f. So we have 3, 2x minus 5. And then if we want the inverse, we have like this. So we'll divide by 3, 2y minus 5. And then we will add 5 and then divide by 2. So we're going to have x over 6 plus 5 over 2. All right, 25, we want g into the inverse of x. So, g into the inverse of f. So if we have, so let's find the inverse of f. So we've got x equals root y. Square both sides, so we're going to have x squared equals the inverse of f. And we're going to substitute g into that. So f inverse of g is going to be 2 to the x squared. So 2 to the 2x. And for b, we have that equal to 16. So with this, I'd probably just write, you could do with logs, but we can just write the same base where the exponents have to be equal. So x is 2. Okay, solve the equation. Okay, so let's find the inverse of both of these. So we have x equals 3y minus 5. So x plus 5 over 3 is the inverse of f. And for g, we've got x equals y minus 2. So the inverse of g is x plus 2. And if we have g into the inverse of x, so we're going to have x minus 2 plus 5 over 3 equals f into the inverse of g, so we've got 3x minus 5 plus 2. So we're going to have x plus 3 over 3 and 3x minus 3. Let's multiply by 3. So x plus 3 equals 9x minus 9. And then we're going to have 8x equals 12. So x is going to be 12 over 8, or 4 goes into 12 3 times, 4 goes into 8 twice. Okay, so we need h at x. That's going to be f into g, so we're going to have 4 over x plus 2 minus 1. And then if we find the inverse of that, we're going to have x equals 4 over y plus 2 minus 1. So we add 1 and cross multiply. So we're going to have x plus 1 times y plus 2 equals 4. We can just straight up divide by x plus 1 and then subtract 2. And that's the function, 4 over x plus 1 minus 2. Okay, next. So this one, if we want f of g inverse, this is what we did in class. This is going to be the inverse of g inverse of the f inverse. Okay, so, or we can do either one of these, really. So we could substitute g into f. So f of g is going to be x cubed plus 1. And if we want the inverse of that, we could do x equals y cubed plus 1. It's probably easier. So x minus 1 equals y cubed. So we've got the inverse is going to be the cubed root of x minus 1. Yeah, because this way we'd have to solve for the inverse. But let's just try it anyway. So if we have to find the inverse of f, that's going to be x minus 1. And if we do the inverse of g, that's going to be x to the 1/3 or cubed root of x. So if we do the f inverse, x minus 1, into the g function, g inverse function, which is x to the 1/3, that's this one, which is exactly what we got. All right, 29, g of x is f of f. Okay, so we're going to have f of f is x over x plus 1 over x plus 1 plus 1. And just to go over how to do a compound fraction, this is going to be x plus 1 over x plus 1 when we make the same denominator. So then we'll have x over x plus 1 over 2x plus 1 over x plus 1. Those will cancel when we would flip and multiply. So we have x over 2x plus 1. Can't do anything more with that. So now we want g of 2. So this is equal to g. So if we want g of 2, so we're going to have g of 2 over 2 times 2 plus 1, which is g of 2 over 5. So we substitute that back into our g function. So 2 over 5 over 2 times 2 over 5 plus 1. So that's 2 over 5, and that's 4 over 5 plus 1, which is 5 over 5, 9 over 5. So it should be 2/9. Okay, find an expression for f inverse. So we'll have x equals 3y minus 4 over y plus 2, cross multiply and distribute. And then get y's on one side, and everything else on the other. So we're going to have 2x plus 4 equals 3y minus xy, and then factor out the y. So 3 minus x, and then we divide by 3 minus x, and that's the inverse of f. Okay, so now the domain of the inverse is that x can't be 3. All right, this is domain of the inverse. This is also the range of the original. Y can't be 3. All right, this is the domain of f up here. This is the range of the inverse. Y can't be -2. All right, 31. So we've got to complete the square here. So x squared minus 6x, half of the middle term squared is 9. So we can't just add a random 9, we subtract 9 as well. This factors to x minus 3 squared, and this is 4. So that's A. B, hence, find the inverse function. So we're going to have x equals y minus 3 squared plus 4. Subtract 4. The square root. And then add 3. And that's the inverse of x. But we have only the x greater than 3. So we're only going to have the positive of this. Okay? So because if we graph this thing, this is a vertex at 3, 4. And it opens up, right? Because positive x squared. But it's only good for x greater than or equal to 3. So this doesn't count, okay? So if we flip this over our y equals x line, we're going to have at 4, 3 for our inverse function. That works. And it's going to be like that, okay? So our domain, for this one, the domain and range of the original function, we already were given the domain is x greater than 3, and you can see the bottom y is 4. So all the y's are going to be greater than or equal to 4. And this is going to switch for our inverse function. So all the x's are going to be greater than or equal to 4. They're all greater than or equal to 4. And all the y's are greater than or equal to 3. All right, 32, calculate f of f at 1. All right, f at 1 is 3 because of this, and f at 3 is 2. G inverse of f at 4. So f at 4 is 1, and then we want when is g 1? Well, it's at 3. So this is 3. Find a solution of the equation f of g at x equals 1. So for this one, C, we want to substitute g at x into f and get 1. So basically we want, when is f 1? Well, that's f at 4 is 1. Okay? So we want g at x to be 4. So that's going to be at 1. X has to be 1 here. Okay? Because g at 1 is 4. Okay, so for D, we want g inverse of g at 2. So those are undoing each other, so the answer is just 2. So for this one, the graph of the function f, sketch inverse. Okay, so we need to just switch these points. So negative 2, 1 becomes 1, negative 2. 6, 9 becomes 9, 6. And we have intersections here and here. So we can just connect. And you can get like, here's 4, 3, so 3, 4. So we can connect these like that. All right, here's fg given by that and that. The function f of g, except on that interval. Calculate the value of a and b. Okay, so let's find out f of g. We have square root of x squared plus x minus 2. And if we factor that, that's x plus 2, x minus 1. And remember the domain of a like square root, what's under the square root has to be greater than or equal to 0. So we have zeros at negative 2 and positive 1. And it's opening up because of x squared. And it's greater than 0 when it's less than negative 2, less than or equal, or greater than or equal to positive 1. So it's defined everywhere except, so it can't be negative 2 to 1, and this means that their -2 and 1 are not included because they're included here in the domain, okay? Another way to write that is like -2, 2, 1, whatever. Okay, for B, find the range of f of g. So we're going to use the calculator. So here I took a picture of the calculator and you can see the lowest y is 0. So we've got that the range is y greater than or equal to 0. All right, 35, consider the functions. X is greater than or equal to a, x is less than or equal to b. Given that f inverse, g inverse exists, find the smallest possible value of a and the largest possible value of b. So we basically need to find the vertex because if we have a parabola, this is not passing the horizontal line test, so it can have a inverse. So even like a little bit, you know, it's not passing. So it needs to start right there and then we'll have an inverse. So to find for the f of x function, we need to either complete the square or find axis of symmetry. So -12 over 2a. So that's going to be x equals 2. So we know that x is going to be greater than or equal to 2 for that function. And for g, we have -12 over 2. Yeah, so the same. So x is going to be less than or equal to 2. Within the domains, determine in A, find the inverse at 7. So for B, we'd have 7 equals 3x squared minus 12x plus 7. And when we'd subtract 7, we'd get 3x squared minus 12x. And then we'd factor out 3x, and that's going to be x minus 4. So x is 0 or x is 4. And clearly, x equals 0 cannot be 1 because our domain is greater than 2. So only x equals 4. And with g, we have 3x squared minus 12x plus 7. And then we would have the same thing, 3x squared minus 12x, and then factor out the 3x, x minus 4, so x is 0 or x is 4 again. So 4 is not in the domain because it's less than or equal to 2. So we have 0. Okay, for 36, the function f g, so find g at x given f of g at x is 2x plus 1. Okay, so we have that f of g at x is 2x plus 1. And we want to find g so that, f of g at x equals 2x plus 1. So we're going to take the inverse of f on both sides. All right, so this is going to give us g at x, what we want to solve for. And this on the right side means we're substituting 2x plus 1 into the inverse. So if we find the inverse of this, we're going to have x equals y cubed minus 1. So x plus 1 is y cubed. So x plus 1 to the 1/3, or the cubed root of x plus 1, that's fine too. That's the inverse of f. So if we're substituting 2x plus 1 in there, we're going to have 2x plus 1 plus 1, that plus 1, to the 1/3. So 2x plus 2 to the 1/3. And if we check it, let's see what f of g at x is, because it should be 2x plus 1. So if we substitute g, what we just found, into f. So x in f is what I meant. Oops, that's a 3. Okay, so those cancel. The 1/3 and third, or 1/3 to the third is 1. So it's going to be 2x plus 2 minus 1, which is 2x plus 1. Great. Now, if we want g at x, so if we have for b, g of f at x, we want that to be 2x plus 1. So we need to do g of f of the inverse. So we're going to have 2 the inverse plus 1. So this is going to be 2, and the inverse is x plus 1 to the 1/3 plus 1. All right, and if we checked it, we want g of f at x, and we want x cubed minus 1 into that. So we're going to have 2x cubed minus 1 plus 1 to the 1/3 plus 1. So those cancel. X cubed to the 1/3 is x, so just what we wanted. All right, 37. F and g are two functions. Given that f of g is that, find f at x plus 3. Okay, so we've got f of g is x plus 1 over 2. So f of g is x plus 1 over 2. Okay, so if we solve for f, so what we're going to do is g of the inverse of g which is going to be g inverse plus 1 over 2. If I find the inverse of g, equals g inverse. Okay, so x plus 1 over 2 plus 1 over 2, changing this to denominator of 2, and we're going to have x plus 3 over 2, and then flipping and multiplying. So this is going to be x plus 3 over 4. This should be f. This should be f at x. Because remember, if we do this, that's just x. Okay, so if we want f at x minus 3, we can do x minus 3 plus 3 over 4 into this thing. So that's just going to be x over 4. All right, 38. Define for x less than or equal to 0, f at x, find the expression. Okay, so we have x equals y squared minus 1 over y squared plus 1. And then cross multiplying. Xy squared plus x equals y squared minus 1. Y's to one side, everything else to the other. So we're going to have 1 plus x equals y squared minus xy squared. And y squared 1 minus x. When we factor it out, so y squared is going to equal 1 plus x over 1 minus x. And if we take the square root, we're going to have plus or minus 1 plus x over 1 minus x. So if x is less than 0, we're going to take the negative function. So the inverse is going to be the negative 1 plus x over 1 minus x. All right, the following diagram shows that. Find the inverse at 1, so that's when y is 1. So this is going to be 0. The inverse at 0 is going to be this thing. And the inverse at 2. I think we have to use graphing calculator for that. Okay, so if we want where it intersects when y is 0, so the inverse at 0, you can enter 0 in here and find the intersection. You could have also found, you could have also found the 0, but, oh my gosh, I'm already here now. So that's the answer to A double I. If we want when y is 2, we put in 2, and that's nice, it just does the intersection, so it's the 0.682. So the first one was negative 0.682, this is 0.682. And then for B, if we want when the inverse equals the function, remember this is on the line y equals x, okay? Oops. So if we clear that, push x, so this is when, because this will flip over and it'll look, you know, like that or something. And yeah, it just intersects on the line y equals x. So x equals -1 there. All right, 40. Functions given by this. Find f at 0. So f at 0 is going to be 1. And then we want, yeah, f at 0. So that's f at 1. And that's going to be 2 minus 8 plus 1, so -5. For B, express the function like that. So we want to complete the square, factor out a 2 from the first 2, and then half of the middle term, -4, squared is going to be 4. So plus 4, but we didn't just add 4, we added 8. So we have to subtract 8. Factoring that, it's going to be x minus 2 squared, and then -7. So this is a parabola with vertex 2, -7, and it's opening up. And that means for C, the range is going to be all the y's greater than or equal to -7. For D, the inverse function, find the inverse function. Okay, so first of all, x equals 2y squared minus 8y plus 1. So if we want to solve this for y, we have to get this equal to 0, because this is essentially quadratic. Well, it is a quadratic. Plus 1 minus x, where, so if we want to solve for y, that's -b, so 8, plus or minus the square root of b squared, minus 4ac is 1 minus x, all over 2 times 2. So 8 plus or minus 64 minus 8 times 1 minus x. I don't know how far down they want this to go. So we can probably just leave it like this. So if x is less than 2, then we are going, so we've got the domain of the original and the range, so we should have x's greater than or equal to -7, because remember the domain of the inverse is the range of the original. Oh, and that, so this is the domain, the range is y less than or equal to 2. So here I just wanted to do it down to what they had. So yeah, now we have 2 plus or minus square root of 2, 7 plus x. If I bring this under a square root, that becomes 4. Okay, so that's where they get the 2. And yes, they are right, it should be the -1. Because our original function is good for x less than 2, so this doesn't count. And when this flips over the line, y equals x, we're going to have -7, +2. So like this. Okay, so I did a better sketch. Because the black function is having vertex 2, -7, and the y-intercept was 0, 1. And then I flipped those points. So this is -7, 2, and this is 1, 0. And you can, like, if this was, you know, if we would have flipped this over, that would have been up here, and that would have been the positive, okay? So this one is 2 minus the square root of 7 plus x over 2.